In problems 1 through 4, the directions say that we're supposed to simplify each expression into a single trigonometric function. A good way to start doing that is to rewrite everything in terms of sine and cosine. Once everything's written in terms of sine and cosine, in this case we can go ahead and multiply those two fractions together to get a single fraction. And then sine over cosine translates into tangent, so that's our final answer for the first one. We can start problem 2 just like we started problem 1 by rewriting everything in terms of sine and cosine. Then in the denominators of the fractions on the bottom of our big fraction, we'll want to go ahead and get a common denominator so that we can combine those two fractions into one fraction. And now that we've done that, we can see that both in the numerator and denominator of the big fraction, the smaller fractions have denominators of cosine, so we can cancel those out. And now in the numerator of this one, 1 minus cosine squared is alteration of the Pythagorean identity, and it's the same thing as sine squared, so we can rewrite that fraction. Now that we've got sine over sine squared, we can go ahead and cancel one of those signs out. And that leaves us with 1 over sine theta, which is the same thing as the cosecant of theta. In problem 3, everything's already written in terms of sine and cosine. In this case, both of the terms have a sine, part of the term, that we can go ahead and factor out. And once we write that in factored form, what's inside the parentheses, sine squared t plus cosine squared t, that's the Pythagorean identity, and that's equal to 1. So essentially we've got sine of t times 1, which of course is just sine of t. For problem 4, it's possible to start it out by rewriting everything in terms of sine and cosine, but it actually makes more sense in this case to check your list of identities and formulas. The denominator on this one is one of the Pythagorean identities. 1 plus tangent squared turns into secant squared. And so we can rewrite this as secant over secant squared, and then go ahead and cancel out one of the secant squareds, which just leaves us with cosine.